Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about FIR ideal band stop filter with the frequency response. As previous class we have discussed and integrated, and then we have finded a HD of n. So this is the plot, and then we have finded this HD of n also. Now we are going to find the individual values. So first thing we need to find a HD of 0. So HD of 0, if you substitute this, so this is the final expression. So look at this, 1 divided by n pi. So once if you substitute 0 here, 1 divided by 0 becomes infinitive. So we cannot use this method. So we can use two methods will be available. One is we can use this before integrating expression, or we can use limit method. You can see that. So for n equal to 0, I am putting, so h of 0 equal to, I am using here as a limit method, limit n tends to 0, so we need to take the expression sine of n pi divided by n pi plus sine of n pi by 3 divided by n pi plus sine of 2 pi n divided by 3 divided by n pi. So we can use this limit n tends to 0 formula. So once if you substitute it, we get this 1 plus 1 by 3 minus 2 by 3. This is the actual values. So we combine it, we get a final result of 0.667. So this is for a h of 0. Now we need to find a h of 1, 2, 3, 4, 5. So we know that symmetry property, as we discussed previously, I show you it again. The filter coefficients of symmetry about n equal to 0, that satisfying the condition h of n will be equal to h of minus n. So by using this, I can write it as h of n 1 will be equal to h of minus 1, h of 2 equal to h of minus 2, h of 3 equal to h of minus 3, h of 4 equal to h of minus 4, h of 5 equal to h of minus 5. So by using this symmetry property, instead of finding 2 times, I can find only 1 time. So once if I find a h of 1, that is equal to h of minus 1 also. So that's why I am writing here as a h of 1 equal to h of minus 1 equal to, I am taking the formula and substituting the value n equal to 1 here. So sin n pi, so n is 1, so sin pi, plus sin of n pi by 3, so n is 1, so sin of pi by 3, minus sin of 2n pi by 3, so n is 1, so sin 2 pi by 3, whole divided by, we have n pi, so n is 1, so 1 into pi will be pi. So once substitute this, we get value is 0, because sin pi is 0. Similarly, this value is also cancelled, so we get only 0 here. Now we need to do it for a 2, so h of 2 equal to h of minus 2, that will be equal to sin 2 pi plus sin of 2 pi by 3, because we have sin n pi, so n is 2, so sin n pi becomes sin 2 pi. Here we have sin of n pi by 3, so n is 2, so sin 2 pi by 3, minus, so here we have sin 2n pi by 3, so 2 into 2 will be 4, sin of 4 pi by 3 divided by 2 pi. So once if you substitute the value for this, we get the value of 0.2757. This is for h of 2. Similarly, we can do it for h of 3. So h of 3 will be equal to h of 3 minus 3, that will be equal to sin of n pi, so sin of 3 pi, plus sin of, we have this value of n pi by 3. So n is 3, so 3 pi by 3, so 3 will be cancelled, it becomes sin pi. Similarly, minus sin 2 into n pi by 3. So we take this value, look at this, 3. So 2 into 3 pi divided by 3. So 3 will be cancelled. We get only a sin 2 pi. So actual expression divided by sin n pi. So n is 3. So sin 3 pi. So if you substitute this also, we get a value of 0. Now we find a h of 4. So h of 4 will be equal to h of minus 4, that will be equal to sin of n pi, that will be sin 4 pi, plus sin of 4 pi by 3. So that is sin n pi by 3. So n is 4, sin 4 pi by 3, minus sin of 2n pi by 3. So 2 into 4 into pi divided by 3. So 2 into 4 will be 8, sin of 8 pi by 3. So this is the value, whole divided by n pi. So n is 4, 4 into pi. So this is the value for h of 4. We simplify, we get minus 0.1378. Now we can find it for a h of 5. So h of 5 will be equal to h of minus 5, that will be equal to sin of 5 pi plus sin of 5 pi by 3 minus sin of 10 pi by 3 whole divided by 5 pi. So this value also 0. Now we can find it for a filter transfer function. We know that h of z equal to h of 0 plus summation of n equal to 1 to n minus 1 by 2 h of n into z power n plus z power minus n. So look at this, h of 0 we have the value, h of 1 we don't have value, h of 3 also we don't have value, h of 5 also we don't have value. So we have value only for h of 0, h of 2 and h of 4. So we can substitute. So I am substituting this h of 0 value is minus 0.667. Now I am going to find substitute value for h of 2 and h of 4 inside this. So if you substitute h of 2, this value will be equal to 0.2757 into z power 2 plus z power minus 2, because we have a z power n plus z power minus n. And then 3, 5, 1 will be 0, we can skip it. And then we have 4. So minus 0.1378, so this value minus 0.1378 into z power n plus z power minus n. So we can substitute here. So this is the transfer function h of z. Thank you.